All right. Space science, huh? Expensive business. What is it? I don't know. Let's look at it this way. Pop quiz. Let's take a guess. All right. How much percent of the federal budget does NASA get? Take a rough guess. 5%? 10%? 15 maybe? 50%. Exciting. All right. So we had a public survey spanning all across the country, asking the precise question to know what the American public thought that NASA was getting from the federal budget. And the person that came to the fore at the end was, they said, an average person said 20%. Fair call to the final answer? Well, let's have a look. For every tax dollar that the average American spent, and if you kind of distribute it as 100 cents, what NASA got was half a cent. I mean, that's kind of really far away from the actual answer, right? But what this brings to the fore is the main agenda for the talk tonight, that the average person might be overestimating in first place what NASA is actually getting. So when we are saying NASA is expensive business and we should probably not be affording it, we are probably overestimating what NASA gets in the first place. But forget about that, we have taken that out of the context. The next bigger question comes, is investing on space a good idea in the first place? Why do we say this? Well, people come and ask me that why should we care about solving problems and finding answers to solutions on other planets and out into the solar system when we don't have solutions to problems on our very own planet? Why should we care about landing a rover on Mars or going into the edge of the rings of Saturn when we have problems like energy crisis, unemployment, poverty that are yet to be solved right on our planet? Well, this is how I'm going to answer this. Over the past 1 year, working as an engineering intern at NASA's Goddard Space Flight Center here in Greenbelt, Maryland, I've interacted with a lot of scientists and engineers there, and through my entire journey, seeing the process, what happens inside NASA, I can say with fair conviction that for every single penny that NASA gets, we are getting much more impact. And today I'm going to give you a window about what exactly is that impact. Okay, I'm going to throw around some things here. Batteries, cellular communications, earthquake-proof buildings, solar panels, GPS navigation, artificial limbs, LASIK eye surgery equipment. What does all these things have in common? Well, surprise, these were technology partly or completely built in conjunction with what NASA developed first. So this was technology that actually got root sometime or the other during the space program when we sent people and rockets out into the outer space and eventually onto the surface of the moon. So this is kind of the technology that initially kind of took roots there. Interesting, right? Let's go into some more specific interesting examples. This machine was responsible for taking human beings to outer space for over 30 years. This is what we call as the space shuttle, right? Favorite vehicle for NASA for a long time. So the engine that you see on the right side, on the left side, is the engine that could function from a range of minus 400 degree Fahrenheit all the way up until 6,000 degree Fahrenheit. And by the way, that is more hotter than the melting point of iron. So this engine had the scale to work at those frigid temperatures. What did NASA eventually do with the technology learned from this experiment? They went ahead and partnered to build one of the largest solar plants ever built in the country during that time. And this today in Nevada is powering 75,000 homes. Incredible, right? That is huge amount of renewable energy being cultivated there. What about GPS? We can't even imagine a life without GPS, right? Google Maps, we don't even think about the technology that goes into it when you use it every single point in time while you go out to a new place. And it turns out that GPS constellation of satellites wouldn't have been possible without the launch prowess that NASA developed during the 1970 to 1980 era. So we have a lot of satellites today, specifically concentrated on giving GPS services. And mind you, it is free. You don't even pay a single penny out of your pocket to use GPS today. Amazing, right? What about weather monitoring? So this is really exciting because at NASA Goddard, we use a lot of software algorithms to take data from the satellites to predict how the wind motion is moving around, how the soil moisture is moving around. And we always get predictions on our news channels saying so-and-so hurricane is going to hit the coast in, let's say, like 3 or 4 days. Now what this is giving us is very critical information, giving us sufficient time to evacuate the critical area, enabling us to save a huge number of lives. And we are not realizing that this technology is being developed, the algorithms are calibrated, and the satellites to do this specific work is sent and developed by NASA. Something that we don't see, right, in news. This is a very unfortunate map. We can see poverty kind of isolated in certain section of the world. This map is here to tell you that the reach and scale of NASA is not just the country, but it is span the world. It can span the world. What can we do to solve this problem? Well, we can have a lot of answers to that. One particular way we can solve this problem is probably kind of generating a huge amount of money to buy food and pump it into Africa. Well, that's not a problem which is taking longevity into scenario. But what NASA did is, they developed a satellite called SMAP, whose only job is to get soil moisture and detect famines and droughts, specifically in the African region, and send a team to Africa to train the farmers to use this data in order to predict how they can use the data which can increase their crop yield, increase the usage of soil moisture in order to get better crop yield. That way we are teaching them to make their own food for themselves for decades to come, and not just a one-time investment, right? Perhaps the most important reason to invest in space is the science and technology dividends that we have brought all through these years. Think about this. It has brought a change in cultural mindset, motivating people like us to be scientists and engineers. And even if we are not scientists and engineers, we all are benefiting from the rise in economic activity that space has brought to this country. So when someone comes up to me, or when someone comes up to you and says that we should probably not be investing in space, then we are taking away just that one little thing that we have to make the technology for the future, to make the transportation for the future, or probably make the home for the future. So think of this as an investment and not as an expenditure on your tax dollar, because being fearless is about persistently spending in the right things in spite of failure, because you know you are eventually going to succeed, which is what we are doing right now. So the entire point is, it is the eventual perception that's going to make all the difference. Thank you, guys.